Hello everyone, my name is Vikas Kumar and I will be presenting my paper Think Hierarchically, Act Optimally, Decoupled Hierarchical Planning and Execution for LLM Agent. So this paper was accepted in the LLM4Planning workshop. So what are the current challenges in the LLM based task planning? We have seen in the literature that LLM shows the strong reasoning and tool use and the planning capabilities, but the problem still exists with the long horizon tasks, and the limited exploration is limited for the problems where action space is very high, and especially for the models around 7 to 8 billion, they hallucinate around hallucinate around many decision making, and the long context memory is poor. So there are two problem gaps, like two problem. One is flat planning, and second is hierarchical planning. So these are the two areas where it is explored, and we will like to propose something related to it. Talking about the background and related work, so basically we can classify or categorize the task planning solutions in certain categories. One is prompt based planning. Second, prompt based planning, where what happens is there are certain techniques like chain of thought, react. So they are in these techniques. We just provides a certain prompt to the LLM, and it tries to solve that given task using the given strategy in the prompt. And the other approach is the feedback and memory usage. So techniques like reflection, refinement, memory modules, so these are used as a solution for enhancing the task planning capabilities of the LLM. Other area is search based methods. So in search based method, we apply several search based techniques to explore the solutions in the task based planning tasks, like MCTS, tree of thoughts. And the last one is hierarchical planning. In hierarchical planning, what we do is we divide the given task into certain sub goals and then solve those sub goals individually. So these are the existing background and related work. Now we move to our framework, which is decoupled hierarchical planning framework. So if you see here in our proposed solution in React tree, what happens is when a sub goal is given, we divide into multiple sub goals. The LLM choose to decide how many sub goals has to be there, and then it expand it accordingly if it's required by the LLM agent. And only at the act, when the LLM agent choose act, there we apply the MCTS. So MCTS, we use standard MCTS expansion, the selection, expansion, and the simulation, and then backup. So the core idea, if we talk about, is the hierarchical level planning. In the hierarchical task planning is we have high level planning and then low level execution. So here our contributions is specifically what we do is we generate the sub goals with a given with a chosen control flow by the LLM agent, and then MCTS used to explore the action at low level. So this is what I discussed in the last slide. So in the task is decomposed into the sub goals. Each node here in the problem, each node is an LLM agent with context is from the previous observation and the action space. And action space include primitive actions, sub goal expansion, and reasoning tokens. And the control flow types can be of three types: sequence, where all sub goal must succeed, and then fallback, where LLM can try multiple alternatives, like if something is failed, it goes back. sorry, if something, until one thing is succeeded, it keeps on trying. And then parallel is execute all the sub goals in parallel. And now how MCTS is used for flat action optimization is, instead of executing a single action, explore multiple action trajectories per sub goal. So in MCTS, these are the steps we apply for action exploration. First is selection, then expansion, and then simulation. Simulation is LLM guided rollout, and then backpropagation for the best action. So what benefit does it give is, it gives is we get the best action by just exploring through MCTS. And if we talk about the complexity, is flash MCTS is b to the power d exponential, and because here in our approach multiple sub goals can have multiple exploration, so it's a summation of b to the power di. And now we talk about the experiments and results. So we ran our experiment and evaluation on the ALF-world environment, where ALF-world is a household task planning household task environment, where agent is given us some household tasks like pick and place, clean. These kinds of tasks are given, and agent has to complete those given goals using a sequence of steps. The model we used is Llama 3.18 billion, and the metric for the evaluation is goal success rate. So out of given number of goals, how many goals actually succeeded. In our for our experiment, we took 100 tasks, and if we see the results, we tried on React technique, then React tree, and MCTS, that is flat MCTS, and then our approach React tree plus MCTS. So if you see compared from the MCTS, just applying MCTS, the success rate was 28%, and from our it was 65%. So it's a net gain around 40%, and compared to the preliminary technique React, which is prompt based, we are around 45% increment. The reason for choosing only 100 tasks was because of the resource constraint, and we plan to further improve our experiment to strengthen our result and techniques. So in the conclusion and future work, the current limitation I want to discuss is, currently all the results are dependent on the sub goal quality. So if the sub goal quality is poor, if the LLM does not know how to choose the sub goal, the results will be poor. So in future we plan to explore the techniques to improve the sub goal quality. Then we want to improvise the MCTS, and then we also want to explore this technique on other complex environment like web arena and travel planner. So this was it. Thank you for listening. Any questions?